So we're going to finish up this week talking about inverse functions, lesson 1.5. So far in functions, we've talked about VLT and HLT, the difference between a one-to-one function, what would make it a one-to-one function, whoops. We've talked about even and odd functions. We've talked about the domains of functions. Now we just need to talk about the inverses of functions. In order to be an inverse, the symbol for inverse, by the way, I think you saw this last year, F with a -1. Okay, regular F is just function, and then F with a -1 is called the inverse function. Both of them still have parentheses, X. So the inverse function only exists if the graph is one-to-one. If the graph is one-to-one. If the graph's not one-to-one, then it's one of those trick questions in there, like the cube root question was on your open note quiz. If they give you a graph and it's not one-to-one, then you say it's not possible, and you write no inverse, and then you move on to the next question. Okay, you don't have to waste any of your time. So first, make sure that you check that. All right, the second thing you got to know about inverses, the inverse switches the x variable to the other side. So instead of the problem being y equals, it's going to be x equals. Think of it like switching seats. Like if I was creating an inverse of this classroom, of the seating chart, I would have Haley get up and switch places with Julian. That's an inverse because they are in opposite seats of each other, and they would get up and switch places, okay? Or Lucinda and Sarah would get up and switch. Rachel would not switch at all because she's in the dead center of the class, and so she would not have to move in any way at all. In fact, nobody in that row would have to move. Okay, what would Camden switch places with? An empty desk, right? And she would become there, and then the empty desk would be over there. That's like what an inverse does. Okay, let's take a look at a math problem. All right, so find the inverse and the new domain for the following question. For f of x equals 4 plus 2x over 3. Well, first of all, you'd have to graph that and make sure it's one-to-one. And it is. We're not going to take the time to make sure that it is one-to-one, but I'm going to tell you that it is. All right, it is one-to-one. And so once you know that it's one-to-one, you're going to take the x and you're going to switch it to the other side. And so the problem now becomes looking like x equals. And the 4 is still where it is, and the 2 is where it is, and then what takes the place of where x was is now the symbol for x inverse, f inverse. So an inverse is switching and swapping spots. Now you do the math to both sides to get the inverse by itself. So the fastest way is to drop a 1 under the x, because when you drop a 1, what can you do to both sides? You can cross multiply. So 3 cross multiplies to x, and 1 cross multiplies to the 4 plus 2f inverse. And then what do I do to both sides? Pretty easy? Maybe not? I'm trying to get f by itself. Subtract 4. Okay, so then you'll have 2 with just the f inverse. And then the last thing to have that inverse by itself. What do I do with the 2? Divide. Okay, divide by 2. So I'll have 3x minus 4 divided by 2, and that is the inverse. So you switch the x to the opposite side, and then you start doing math to the algebra so that you have the inverse. This is called the inverse function, and it'll have a new domain. So you ask yourself the two questions. Does it have a square root in it? And does it have a denominator that could be equal to 0? Okay, does it have a square root?
No.
Does it have a denominator that could be equal to 0?
No.
No, because there's no x in it, so it can't possibly be equal to 0. So the domain of the new function is still all real numbers. Okay, let's try another one. Same instructions. Find the inverse and state the new domain for the following equation. The cubed root of x plus 3 minus 1. Well, what's the domain of this function? Is there anything to worry about? The domain is all reals, because the answer to the question, does it have a square root and does it have a denominator, are both no, and so the domain is all real numbers. But our job is to find the inverse. And again, you check the graph to make sure it passed, and it does. It passes HLT and VLT, so it's 1 to 1. So then I throw my x onto the other side, and so it's going to be x equals the cubed root, and then taking the place of where x was is the symbol f inverse of x plus 3 minus 1. So the x moves to the opposite side, and taking its place is the symbol for inverse. Okay, I'm trying to get f by itself. What should I do to both sides? Add 1. So x adds 1. We have the cube root of f inverse of x plus 3. Now I want to get rid of the cubed root. What do I have to do to both sides to get rid of a cubed root? I have to cube it, but you have to cube it as a group. All right, the wrong thing to do was be to cube things individually. You can't do that. You can't cube individual things. You have to cube it as a group. So x plus 1 has to be cubed as a group. Then on the other side, you've gotten, by doing that, the cube root on that side is gone. And then the last thing to do would just be to minus the 3. Oops. Minus 3, and then we have f inverse all by itself. And that is the equation now for the new inverse. Its domain, we'll check, does it have a square root? No. And does it have a denominator? Again, no. So this one, its domain is going to be all real numbers again, because it didn't have either of the two things we had to watch for. So let's just look back over the process. Both processes start with checking HLT and VLT, and then once they pass it, moving the x to the outside, and then solving to get the new inverse by itself, and then checking your domain. I don't care what the instructions say on the homework. I want you to find the inverse and state the domain. Okay, even if they say, draw graphs and do all this stuff, I put it in Canvas. I just want you to find the inverse and state the domain. Okay? All right, have a great